Hello everyone. So the problem today which we are solving is the maximum number of subsequence after one inserting, right? So this is the second problem of this contest. Let's quickly read the problem statement. So you are given a string S consisting of uppercase English letters. You are allowed to insert at most one uppercase English letter at any position, including the beginning or the end of the string, right? You need to return the maximum number of LCT subsequences that can be formed in the resulting string after at most one insertion. So what is a subsequence? Is an empty string that can be derived from a string by deleting some or no characters without changing the order of the remaining characters. So first of all, let's read or understand this problem with this test case, right? LMCT, right? LMCT, right? So what is the problem stating? That you need to count the number of subsequence which has L, C and T. So if you see the answer now, we can insert L at the beginning of this S and the string would become double L MCT. And now if you look, we have the subsequences as L, C and T and L, C and T. So what are the number of subsequence count? It is 2, and that is the maximum that you can produce, right? So you will return a 2 over here, right? Similarly, if you look at this test case, it will return 4, and the reason for this is you can still insert a L in the first position and that will result a 4, right? So before proceeding to our solution, let's talk about some cases, right? So if you want a string to be LCT, right? If you want to get a subsequence of LCT, right? Tell me first observation, if you think, is nothing but if you want to place a L, what is the correct position to place an L, right? Think of this greedily, right? अगर तुम्हारे को L subsequence चाहिए, right? It should begin with L, right? After that C and T might be at any position, right? That won't bother you. So the best position to place an L would be at the first position, right? So L should be definitely placed at the first position, right? Okay. T means if you want to place an L, that should be in the first position. That's what I will try to mean, right? If you want to place a T, that should be definitely at the last position. Think of this greedy, right? If you had many multiple L's, you want a T to be at the last position so that it can cover all the LC permutations that could be there. You're getting it? So T should definitely be on the last position. L should be definitely on the first position, right? Okay. Now let's quickly discuss where should we place a T, right? Now this is a big doubt for you, right? But before solving this doubt for C, let's talk about how would you find the number of subsequence which has an LCT, right? What do I mean? Let's take up this test case, right? This test case, right? So if you see, we are inserting L at the beginning, right? So ultimately the string will become double L C double CT, right? This will be the final string, right? So if you look at this C, right, tell me one thing, how many subsequence could this C make if he wants to take L before this? क्या मतलब इस पोजीशन, इस C वाले पोजीशन से what are the values that we can get before, मतलब कितने पीछे L हैं? Why is this useful, right? देखो, if you had a C over here, right, you could take this in the subsequence. If you had this L, you could take up this in subsequence, right, and place it, right? Wait, let me draw this clear for you, right? Let's say you want to place an L, right? You can place this L, you can place this L, and still these two C will be valid for you. Let me call this as first, let me call this as second L, right? So these two are the valid positions, right? Now we had one T over here, right? So let's for example take, we had 3 T's over here, right? So अब क्या कर सकते हो, इस साइड जितने भी values हैं, all would be the valid one for these two. Let's look at how that will be valid, right? What I'm trying to say, double L, C and triple T, right? How many subsequences could be formed using just this C? Let's look at that, right? So you can start with this L, right? You can place this L, this C and this T, right? Now this L, this C and this T, again this L, this C and this T, right? Now let's look at this T, L, right? L, this C, again these three, this T and this T. So if you closely think of now the test case, it will be clearly mentioning, it will be clear to you that for a single C, right, if you count how many L were before it, right, and how many T's were after it, right, and if you simply multiply them, right, if you simply multiply them, that will be your answer, right. देखो इस तरफ 2 है, right, 2 and इस साइड 3 है, so 2 into 3 will be your answer. Getting it? So we can easily compute this, right. So if you think, I can say my answer 1 will be if I place an L at the beginning, right, L plus the string, right. Answer 2 might come from if you place an S plus a T at the end, and answer 3 will be placing a C at any random position. But how will we figure out which is the best position for ourselves, right? Now let's look at it, right? Let's say all test cases are saying, however, we can place a C at any positions as well. But let's say I had L, C and T, right? So if you think, right, if you find out how many L are behind and how many T are after this C, right? So let's say for a second think that this is also a blank space, right, and you could place a C over here, right? So you would try to maximize this L into T times, right? Let's call it product, right? Let's for a second call it a product, right? So you would want to place a C at any given positions such that the product of L behind it and the T's after this position is maximized. You are not placing it over here, you are just calculating it, right? Because placing it would cost you that would take big of n square time, right? And if you look at the time constraints does not allow you a complexity which is big of n square, right? So that is the reason you need to write a code which does not go too big of n square but only in big of n. So hypothetically you are trying to place a C over here, right? You are not actually placing, you are just saying what if you would have placed a C over here, right? Let's take an example that would be way more clear to you, right? Yes. So tell me, if you think of this, if you place a C over here, that will be give us the best answer, right? Why? Because 2 L are behind this and 3 T's are behind after this, so this would be the best position. Now how did we calculate this? We calculated this using, we are trying to place, let's say trying to place a C over here. If you try to place a C over here, only 1 L is on the left side and 4 T's are on the right, so that will give me answer of 4, right? If you place over here, 2 L are on the left side, right, and 4 are still on the right side, that will give me an answer of 8, right? Let's try to place over here. Now if you place over here, 2 on the left, 3 on the right, so 2 into 3, 6. If you place over here, 2 on the left, 2 T's on the right, so 2 into 2, 4. Getting it? So if you place over here, so you can try all of them, but this will be the maximum, right? So what are we trying to do? We are trying to find the position, right? Find the position where you could place a, I'm not writing it because my mouse cursor will make a lot of sound. So you are trying to find a position that will yield you the maximum product, right? That will yield you the max product, right? So now how will you find this product in big of 1, right? Because you can't again traverse on the whole loop, because that will take you a time of big of n again, and it will result you a big of n square time complexity, right? So what you can do is pre-compute it, right? So I will pre-compute how many L are on the left side, I will pre-compute how many T's are on the right side at every index, and I will multiply them and find the maximum out of that, right? So the logic will be clear to you. Last step that I want to make you clear is, let's say I already had an LCT, right? So I will first calculate what is the answer of this subsequence, how many subsequences are there which will be in my answer, right? So first I will calculate it, and then I will try to place a C over every index and try to find the maximum out of it, right? Now let's say we got a maximum 1, right? So that one should be added to your answer, right? So your basic answer, let's say LCT, right? Let's try to look at this. So if you look, this is only one subsequence is possible, LCT. So your answer is 1, right? Answer is 1. Now I'm saying is try to place a C over here. If you place a C over here, I'm writing it smallly. So LCT, and so if you look 1 and 1. So how many extra contribution will it make? It will make 1 contribution, right? So answer becomes answer plus 1, right? If it would have made 2 contributions, so you will add it in your answer, right? So if you look now, LCCT, now you see LC and T, LC and T. So the answer becomes 2. So you will find your answer without adding any C or L or T first, right? And then after finding that answer, you will try to find the maximum product of left L and right T, right? Left L and right T, and any value which gives you the maximum, you will store it, and after that simply add it in your answer plus equal to maxi. This is the whole logic of the problem statement. Now quickly let's look at the code, right? So first what I'm trying to do is I'm making a string s1 which is equal to L plus s1, right? L plus s1 means, let's say s was LCT, you added L, so it becomes LL double CT, right? String s2 is s plus t, right? You are adding t to the very end, right? LC double t, right? Okay. Now you are finding the answer 1. Answer 1 is find s1. I'm calling a function which calculates how many values are valid. I will show you this function as well. Answer 2 is again find s2. We are passing the string s1, s2, and answer 3 is s. That means you are not adding any value to it and finding the answer, right? Now let's look what does the find function do, right? So what does the find function do? It first calculates how many left में L है and right में how many T's are there, right? So it's basic. If you look at the code, that won't be very tough to understand. S of 0 is equal to L, so left में L will of 0 will be 1, and you compute from 1 to n. If you get an L, you do a plus 1, right? And if similarly for T also, right? If the last element of the string is T, then you write में n minus 1, you add a value to 1 to it, and then again you calculate from backwards to the 0th index, right? And if you get a T, you do a plus 1, or else you repeat the value of it, right? So this function finds how many elements are on the left में L and right में T, right? Okay. Now what I'm trying to do is I'm traversing from 0 to n. If I get a C, right, what I'm doing is answer equal to 1 LL, because answer might be large, right? So that's why I'm doing 1 long, right? So how many left में there, how many i's are there, and how many right में कितने T है, right? These are the two things which we are finding. Let's say we had a C, so 2L, last example only, 3T. So this C alone could make 2 into 3 possibilities. So that's what we are storing in our answer, and finally we are returning the answer. So you could clearly see we send the function s1 which had only an L extra added to it. We pass the function s2 which had an T added to it, and only the string s in answer 3. Okay, now again we are computing it. Again we are computing the value, that what is the answer for the plain s string. I think this could have also been done in the function as well, but still I calculated it. This was my contest solution only. So if you see, we traversed from n and did the same thing as we did in that find function. Similarly we did for the same thing for the right function, and now we are starting from 0 to n, right? So for the left value, what is that? Left में how many L are there, right? Left में L for I, right में T for I, and what are maxi is equal to maxi comma left into right. So this will give me an answer maxi, and ultimately in my answer 3 I will store answer 3 plus maxi. And out of these 3 values, answer 1, I tried all 3 possible ways of placing an answer 1, answer 2 and answer 3. I place an L, place a C at any position, place a T at the very end, and out of these 3, the one which will give me the maximum will be my answer. So at the very last I'm returning max of answer 1 comma answer 2 comma answer 3. So if you look at the time complexity, it is big O of n, because we have not traversed or made any loop which is nested loop. So the time complexity is big of n. the space complexity is a bit heavy. It's not big of n square, it is also big of n, right? We are storing the prefix, right? Prefix left में कितने l है and right में कितने t है, right? So it is big of n only, right? So that's it, that's the code. If you try to submit it, it will get accepted as well. So I will leave the code in the comment. If you have any doubt, you can ask me in the comments. I will try to answer them as well. And if you have any more questions which you want me to provide solution of, you can also tell in the comments. Thank you for watching. Please do subscribe my channel.